In 5.3, we're talking about rates, which we've been talking about over the last few days in math because we knew they were coming, but also in science because we were using a really good example of rates when we were calculating speed from our time and our distance. And so hopefully this will make even more sense to you since we've been talking about it. And by the end of this section, I want you to kind of consider this statement. I will be able to make tables of equivalent ratios to compare quantities, and I will also be able to solve unit rate problems, including those involving unit pricing and constant speed. And again, we talked about both of these things, unit pricing when we did the grocery shopping activity and constant speed when we talked about the ramp height investigation. And at the end of this section, I want you to really think about, are you able to do these things confidently? And we'll try to check in on that. A few really important vocabulary pieces that are going to come up in this section are rate. And the definition of that is that a rate is a ratio of two quantities using different units. And so, for instance, if we talked about speed, one unit was time and one unit was distance, and those are two different units of measurement. So that's what makes a rate just a little bit different than a ratio. And another one we'll talk about is a unit rate. And the important part about a unit rate is that it compares a quantity to one unit of another quantity. So unit rates always have a denominator of 1 or get down to 1 unit. And finally, equivalent rates, very much like equivalent ratios that we just finished up, have the same unit rate. So if you were to put things into a ratio table, they would all end up with the same unit of 1, and they'd be equal to each other. So we'll take a look at that as we're going through these examples. In example 1, we're going to practice writing a rate, and we're using a tool here called the double number line, and that's what we're looking at down here. And the double number line in this case shows the rate at which you earn points for successfully hitting notes in a music video game. And they want us to write a rate that represents the situation. So when we look at this double number line, we can see we're comparing points to notes, and those are two different quantities, which is why we use the double number line here. So if you hit 0 notes, then that means you earn 0 points. And then you can move along the double number line and just interpret it. If you hit 1 note, then you earn 150 points. If you hit 2 notes, you earn 300 points, and so on down the line. So when it says write a rate that represents this situation, we can technically pick any relationship on this double number line, and we're just going to pick this one right here. So one possible rate here would be that you will get 600 points for 4 notes, or for every 4 notes that you hit. So one possible rate is 600 points for every 4 notes. And again, we could have picked any relationship. There are several more to choose from along this number line. In example 2, we're going to be finding a unit rate. And again, check your key vocabulary if you're not quite sure about that. But remember that a unit rate is using a denominator of 1 or comparing something to 1 unit. So our question asks, a piece of space junk travels 5 miles in 8 seconds. How far does it travel per second? And per second would help us understand that we're getting down to 1 second. And we're going to try this one using a ratio table. So we can set up our ratio table here to include distance in miles and time in seconds, and they give us the rate of the space junk traveling in 5 miles in 8 seconds, and they want to know how far does it travel per second. So we're going to try to figure out how to get from 8 seconds down to 1 second, and we know we can do that by dividing by 8 here, and then we remember that if we divide the one part of the ratio or rate in the bottom by 8, then we have to do the same thing to the top. And so we can just write that as a fraction, 5/8, if we want to. If you wanted to use decimal form, you could use decimal form. And in this case, there's actually nothing to simplify because 5 and 8 don't have anything in common besides 1. So when you go to answer the actual question, you would simply say that the space junk travels 5/8 of a mile per second. For number one, because there are several right answers, if you have an answer down that you don't see listed here, just come check with me and I'll help you make sure that you have a correct rate written. Otherwise, everything else should match just like what we have here in the answer key. In example 3, we're going to be finding equivalent rates, and the problem that we're working with says a chef buys 6 pounds of salmon fillets for $51. How much will the chef pay for 9 more pounds of salmon fillets? And again, we're going to work with a ratio table here to help find some of those equivalent rates. In this example, we're going to set up that equivalent rates table or a ratio table, and we'll put cost on top and salmon, and it's being measured in pounds, on the bottom. And they tell us in the problem that the chef pays $51 for 6 pounds of fillets, but they want to know how much he's going to pay for 9 more. So not a total of 9, but 9 more pounds than what he already paid. And the best way to do this is going to be to find that unit rate of how much it costs per pound. And so if we do that, we can divide by 6 here, and then we would divide by 6 up here. And this one is going to require some side math on your part, so just remember to set up your 51 and divide it by 6. And then we know 6 isn't going to go into 51 evenly, but if we started at 8, it would go if we started trying with 8 groups, we could multiply 8 by 6 to get 48, and when we subtract here, then we would have 3 left over, and you know that we can just add a decimal here and a decimal here, and then after that we can annex the 0 and drop it down, and then 6 goes into 30 5 times, so that's going to go after the decimal. Remember, it was really important to put the decimal in the answer there, and we know that 5 times 6 is 30, so when we subtract, it leaves us with no remainder. So that means that the cost is not just 8.5, it would be $8.50, but you can put it in like that or like that. And then we're trying to figure out how much the chef is going to pay for 9 more pounds. So this time we're gonna have to multiply by 9 on both the bottom and the top. And so down here we can get 9 pounds. And again, you'll just have to set up your multiplication and use that decimal. Remember, when we multiply with decimals, you just line everything up to the right and you do your regular multiplication. And then in multiplication, we can't just drop the decimal, but there's 1 digit after here. So we need 1 digit after our decimal down here, which would give us a total of 76.5, or again, it's money, so we'll probably want to put that as 76.50. So the chef pays $76.50 for 9 more pounds of salmon, according to our equivalent rates table. Quick little tip or hint, especially in the area of vocabulary. We have been talking about unit rates here, but when you are talking about the cost per unit and you're dealing with cost here, sometimes we refer to that as unit cost, or we a lot of times also just call that unit price, which is exactly what we did with our grocery shopping activity. So in example 3A that we just did with the salmon, we could have said the unit cost of the salmon was $8.50 per pound, or we could have said the unit price of salmon, and that would remind us that it was per pound because that's one of that quantity. For example 3B, it says you buy 2 pounds of tilapia fillets for $16, and they want to know what is the cost for 7 pounds of tilapia fillets. And for this one, instead of using equivalent rates tables, we're going to go ahead and use a double number line. And you'll notice that when you get used to this, if you can split something up into easy fractions, a double number line works pretty well. So we're going to start by making that double number line. So the first rate that they gave us in the actual problem said that you could buy 2 pounds of tilapia fillets for $16. So that is the first rate that I've put onto our double number line. And again, we said you can kind of work in fractions here. So if we were to do double that, then it would be $32, and that would be for 4 pounds. And then you could do another quantity there, or times 3 of 16, and it would be $48 for 6 pounds. And then we could get one more if we had to on there for $64 if we were going to need 8 pounds. And then even on the in-betweens here, we can kind of think about it. So this is for 2 pounds. And if we kind of put some halfway marks in there, this would be for 1 pound, 3 pounds, and so on. And the reason we're doing that is because, remember, they only were asking about 7 pounds of tilapia. So we kind of want to make sure that we can figure out where that is. And then using this pricing system, if you think about it, then halfway between $48 and $64 would be 56 on the double number line. And so the cost for 7 pounds of tilapia fillets would be $56. And so this is our final answer here. And then just to make sure you're clear on how we got that, again, to get from 0 to 16, when we start looking at relationships, we added $16. And then down here, we just added 1 extra pound from here, but then from here it was 2 extra pounds. So kind of check and see what relationship you're looking for. And up here again, we added 16 to get to the next increment, and down here it was plus 2, because remember this first one was plus 1 to get to 1 pound, plus 2 to get to this one. So in this case, we're adding by equal amounts. And then in this situation that we were actually looking at here, instead of adding all 16, which we would have to get to 64, we only added plus 8 to get to this halfway point, because we were only adding plus 1 to get to this halfway point. So again, takes a little bit of thinking on your part, but just try to figure out and make sure you understand which jump you're making. And remember, we said in adding, which is a little different than multiplying, you can add by one quantity on top and a different quantity on the bottom. So up here we added by 16, down here we added by 2s, and that's okay when you're doing adding and subtracting. When you were multiplying, it had to be by the same quantity on top or bottom.